When we're talking about increasing and decreasing functions, we're asking two basic questions. Where does my graph have a positive slope? And where does my graph have a negative slope? Now, when we ask where, we mean in the x interval. So I have one example to start us off that's a very good level of complexity to introduce us. This graph is of x cubed, let me write that down, minus 4x. So, like I've mentioned in another video about SlopeMan, if I want to find where I have a positive slope and where I have a negative slope, I'm just going to draw a little guy on top of the graph, meaning the upper part of the graph, and say, is he going up or down? So from this section up to this point, he is going up. So I'm just going to draw this little dashed line to show that this section is increasing. And let me see if I can change the color of my pen to show that I'm going in a different direction now. Okay. And then if I draw my little slope man again, he's suddenly going down. Therefore, this portion of my function is decreasing, which is evidence that a function can be both increasing and decreasing, just in different intervals. Sorry that that's ugly. The C won't come out very well. There we go. Okay, and then finally, my last portion of this graph, if I draw my little guy here again, and show which way he's going. He is going up, which means that this is an increasing interval of the graph. And that's a very surface way of showing it. So now that we have these intervals, let me see if I can't use this interface, use Desmos, the website that we're looking at for the graph, to actually find what my intervals are. Okay, there are calculations that I had to do to find the exact numbers that you guys don't need to worry about right now. In terms of increasing and decreasing functions, what's important to know is that this point right here is negative 1.15, continuing for a little while. This is the spot where my function goes from increasing to decreasing. This interval here is increasing. And then at the point x equals 1.15 again, this one positive, not negative, my function goes from decreasing back to increasing. So there's my decreasing function. And then finally, I'm back to increasing. This should just show you that this one function has three different intervals that are important to us. So let's actually write them down and see if we can't practice how to the notation for this. Okay, so to talk about my increasing intervals, I want to say that I started at negative infinity and I ended the increasing interval here, my orange, at negative 1.155. And we're going to go to 3 decimal places because that's pretty typical. We don't always have to go to that portion. And since I started at negative infinity, I'll put a parentheses because it's not something that I can approach. And at this point, it is a closed point, which means I'm going to put brackets. If I wanted to write this using inequalities, I would simply say that negative 1.155 is less than or equal to x. That's one of my increasing intervals. So this is one way to write it. And then let's talk about our decreasing interval, because I want to just go from left to right. So we've written down the notation for this interval here. Let's go to this one. So the center interval is decreasing, and it starts at negative 1.155. Starts at this point right here, or that x value. And from there, it goes along until the x value 1.155. And both of these are closed points, so I'm going to put brackets. And if I wanted to write that as an inequality, I'd put negative 1.155 is less than or equal to x, and x is less than or equal to 1.155. That's my decreasing interval. Now, I have one more interval for this graph at 1.155, and this portion, much like the orange portion, will go to infinity. Infinity always gets a parentheses, whereas a closed point will get brackets. And again, as an inequality, I would write x is less than or equal to 1.155. Now notice that I'm writing everything less than or equal to in that order. If I wanted to, I could flip this and say 1.155 is greater than or equal to x, but for the most part, when we're talking about intervals, we want to go from left to right, from least to greatest. And so that's the more efficient way to write this in this context. I don't have anything else to write for decreasing, so let me just kind of highlight. Let me see if I can highlight my answer in any way. Okay, there are my three answers, and they're labeled based on what type of interval they are. Hopefully, this is clear for you. So, just in case, I'm going to do one more example. Okay, in this graph, I'm seeing something different than what you may be used to. This is the graph of f of x equals 1 over x. This has what we call an asymptote in the center here, where my function starts on the negative side decreasing, and all of a sudden it ends up down from negative infinity up to positive infinity on the other side of my 0. This means that my graph actually doesn't have any 0 value here. It's like it skips over to get from this negative infinity all the way up to the positive. That's just a little description here for you. So let's use SlopeMan to see if my graph is increasing and if it is decreasing, and in which intervals. Okay, so I have SlopeMan here showing me that on the left side of my graph, even though it may not look like it because this is slightly horizontal, he is going down the curve. It is decreasing. Now on the right side of my graph, surprisingly, even though it's on the positive side, he's still going to have to go down the curve, so it's still decreasing. Hopefully that's clear on why the whole graph is decreasing for us. The one problem is we don't have anything at this 0 because, like I mentioned before, it has an asymptote. So even though I have two decreasing intervals, it's not like I can say that the entire function is decreasing. So let me just write those intervals out. Okay, I am decreasing from negative infinity in this interval all the way until 0. Now notice I put a parenthesis here at this 0 because because the asymptote tells me that it is not smooth. I don't have an x value at this 0. And then again, because there's no x value, I'm going to put a parenthesis, and I'm still increasing at 0. Still decreasing at 0 all the way over until infinity, because SlopeMan, written on the top of this graph, will be moving down here as well. Now that may look tricky to some people because they see that this looks like it's going down and this looks like it's going up. That's not how it works. We're always talking from left to right, from least to greatest. Okay? Hopefully that helps.